Hello, everyone. How many of you don't know about WebAssembly or WASM at all? Can we have a show of hands? All right, quite a few people. So we won't be covering like the history of WASM or why it originated and how so. But so very quickly, WebAssembly came out as something that would accelerate your JavaScript environments, your things, your web apps, particularly say games that run on the web, your applications, really complex applications that can run. And now it's more relevant because now we have really powerful devices, right? So we have, on the client side, we have amazing devices from our laptops, our mobiles, and other devices which can support very well. And WASM is not just limited to browser even, it's everywhere. You can have WASM VM in practically a lot of places. And a lot of applications that you're already using might just be using WASM already. So if you use Figma, if you use Netflix, all of them are already using WASM. So the idea is to sort of go through the WASM ecosystem in general and where the WASM ecosystem in Python stands today, and how we can work towards it, hopefully develop it, come together and work around it. How it can potentially relieve us of the heavy workloads that had happened on the server side and move towards a more serverless computing side, towards a more distributed nature of our products. We have a QR code. If you want to follow through the slides, you will find 2 slides in there of different dimensions, whichever one you are more comfortable in. So just to quickly introduce.
Hello, my name is Farhaan, and I work for a company called OpenCraft. My job is to maintain and contribute to OpenEDX, and we write a lot of Rust and Python.
I'm Kumar Anirudha. I work as a product developer, and I build products as an architect. And I work mostly on Python, Rust, Go, and multiple languages in general. So let's get started. Like I was talking about already, so the major advantages that you get with WASM is like you can, because with a lot of languages, you can reduce the startup times. These run on a virtual machine, a WASM VM, so you can eliminate a lot of the security part of it as well. If you want to have a sandbox environment for your users, that becomes the priority. If you want to make things more usable from a user experience perspective, that becomes a priority. And in those cases, you can use WASM. There are several projects which is obviously working towards it, and we'll go through it one by one. Also, if you want to create applications which works across different operating systems, different browsers, and so on, obviously there will be some limitations. The entire ecosystem is obviously, again, quite new, although it has been in works since years now, and even so. Mainly because Python's dynamic nature, WASM becomes a bit more challenging than it should have been. In languages such as, for example, Rust and Go, you can easily compile them, and you can have a .wasm file which will run anywhere, right? Python, we will have to, languages such as Python and JavaScript, which were initially not that strongly typed as well. We didn't have a compile-based language, and we had to go through an interpreter side of things. So a lot of things got really, really complicated when we want to compile the entire project or a particular file as well to WASM. And that's where a lot of projects have gone through different side of paths on how we can approach this problem. We'll be talking about some of those. So,
when we talk about Python to run in browser, the major drawback that Anirudh pointed out is the dynamic nature of it, because it's an interpreted language. How we are going to, run a binary or anything that is compiled form in it. So if you actually Google Python and WASM, the first thing, and it's the epitome of running Python in browser, which comes to your results is Pyodide. And it's a very beautifully written project. It's really amazing in the way how it works. So Pyodide or Pyodide is basically a CPython compiled or ported into WebAssembly or mscripton. And that's how they kind of run Python in the browser. So you are making a whole VM of Python and then pushing it into the browser saying that, OK, run it. What you can do is you can have a REPL shell, and you can perform various operations on it. The thing that we found out that were lagging in the way we were searching for things was Pyodide is not a transpiler. What do I mean by that? Is the same thing, that you make a Python VM or a WASM VM, and you put it in the browser for it to learn. Now, the issue with this is how does, so I compiled CPython and told the browser to run it. What about my extra libraries? What about NumPy? What about other scientific libraries that we have? So Pyodide comes with something called as micropip, which you can use to port your favorite libraries, and then it gets compiled with the same code, and then you can push it in the browser and run, which is beautiful. The way Pyodide has the JavaScript to Python FFIs is amazing, the way JavaScript APIs interact with Python to run it and to execute the code. So, but it's not a transpiler. That means it doesn't translate line by line of what is happening. You just give something to Pyodide, and it just runs it. When we were looking into Pyodide, we actually got a lot of inspirations. So it was a borderline fanboying moment for me, because I was discussing this with Anirudha, and we were in WASM Summit, and Hood was sitting next to us. I don't know if he's here. But there's this really nice pep that he wrote, and which helped us to learn a lot about Pyodide and WASM and Python realm in general. The thing that got my attention, and it was admiring to see that in Pyodide you have patches that is supposed to be streamed to CPython, and you can have a list of patches there. We use a tool to compile it, which is mscripton. There are patches for mscripton that has to be used with Pyodide, and he has a list of patches in the repo there as well. So this is a huge shout out and kudos to all the Pyodide team for putting that effort. I actually wanted to show those patches. I don't know if this is visible. I have tried to make it visible. So if you see, there are patches to CPython here. And these are like small patches which have been maintained, and they have kept being maintained. And same goes with mscripton as well. Let me just show. Yeah, so these kind of patches are there, which was very beautiful to come across, to see, to understand of how exactly the WASM ecosystem is working. Which brought me to the downside, or the reason why maybe we were looking for another tool. And that was because when we tried to load or use Pyodide, there's a huge size of the code base that gets loaded into the browser, which is time-taking, time-consuming. Basically, it takes a longer path to travel to get to what we want to achieve. And too many patches, that means it adds too much time to how much we can give it to maintain. We can, and it feels like a workaround. So mostly, if we can upstream those patches, that would be something, and the work has already been done on it. So that was the reason we kind of thought of experimenting with something other than Pyodide. So we landed up on RustPython. We were writing a lot of Rust at that time, so yeah, we thought, why not explore this? So RustPython in itself is a very nifty and clever tool. So it's just Python 3 interpreter ported in Rust. So whenever you want to write Python, you basically write Rust, and then you compile it. It becomes a bin or a WASM file which you want to use, and then you run Python through Rust. So this, if you see the code here, it's actually doing that, where you have written a Python code, but it is wrapped around Rust, and it's being used. We were like, OK, this is good, this is nice, but there should be something better. That's when.
So if you look at most of the tools, and we did a small benchmarking. We wrote a small fast API, 1 or 2 routes to route a small app, and we ran it through different environments. If you see, obviously, the goal behind WebAssembly might be very different from just shipping the product, right? And if that is a goal, then speed might not be an immediate metric for you. But if we have to run it in production, it's really, really far from where we would want it to be for most applications, for most complex applications that we usually ship out, right? So if we compare it with, let's say, something that is a simple web app written in Rust or Go, we'll see that it's still quite slow. If you compare it with even a small fast API application written and compiled using Pyodide or RustPython, as compared to even Docker, it's still quite slow. But it's obviously a progress, so we cannot obviously discount that. But still, we have a long way to go, and that is where we stand today. The idea is behind all the tools that Farhaan just showed, is that what we are trying to do is we are putting Python on WASM, right? Where the CPython compiler itself is already present, and we are pushing the Python code, and then the WASM is running through that. Another approach that can be achieved is by pushing Python to WASM, which essentially is the compiled language format. This might have a little more work that has to be done there, because all the data types you can think of, all the things that CPython supports from the C APIs and everything, that needs to be ported across, and that needs to be made accessible or being provided for compilation, which means that once this is done completely, you might have almost near-native speed. You might have near-native performance, smaller build sizes that you can distribute easily, and so on. But there are a lot of data types which are still missing, and that's why projects which is big enough, for example, machine learning, AI, and so on, we cannot really run it on WASM at this point. We still have to rely on our servers and GPUs for that. Eventually, we hope that that is not the case, and we can do everything on WASM as it is. So in the Python 2 WASM journey,
yeah, and as Anirudh pointed out, in a Python 2 WASM journey, we landed up on Python 2 WASM. So exactly, I mean, when we got through what is Python 2 WASM, we wanted to understand what exactly it is. So when we started the talk, we said that Python has a dynamic nature to it. So what Python 2 WASM actually does is it compiles the Python code that is written, obviously into something that is machine understandable. Right now, we are saying it can be WebAssembly, but yeah, there is an intermediate level to that as well. And we landed up on this project called Nutica. Now, what Nutica is, or what they say, at least in the README, is they are the compiler for Python, which means that they somehow compile Python code to something that runs as a binary. We thought, OK, let's try it out. So as a good Pythonista, I went to my machine, and I wrote pip install py2 wasm. And everybody accepts that it works, but it didn't for me. I was like, what happened? Why did it not work? After a lot of researching, after reading up a lot, I got to know that so py2 wasm is a fork of Nutica. it's not even a proper fork. Right now, it's just an open PR on Utica. So if you want, you can scan this code and go to this PR and see the comments and discussion that is happening. And they just support Python 3.11.0, not even 3.11.1. And if you're up or down, it's not going to work for you. So yeah, so I spent endless nights debugging, copying file here and there, libpython.a, libpython.c, I don't know what I was copying and trying to make it work so that I can see what is happening. But then somehow, finally, I got this to work. And right now, I think I can show you what it does. So, okay. Yeah. So I'll just delete my files. Yeah, there it is. Is it visible? No, control. Yeah, it's visible. So that's how you run it. So I'll show you what hello.py has. It just has a print statement in Python. So if you see here, it just have a print statement here, but it compiled and it printed a file which is hello.wasm, and hello.wasm, if you see file, it's actually a WebAssembly supported file. So I was very happy with it. At least something is working, and I got to it. But then when I saw how big it is, it was, I think, around 24 MB. Yeah, 24 M. So that was a huge number for me at that point. I was like, what is happening? There's something going on. So what eventually even Utica does is it's just compiled everything or a subset of what I am using. And I'm not using anything else. I'm just using a print statement. So that tells you that it takes a lot of things to compile and get to that point. So yeah, that happened. So how does it work? So basically in Utica, what it does, it compiles your Python code into something called as backend C. Which means it has to get all the imports and everything into a file, and it has to create a big file out of it. And then that C file kind of gets compiled into a WASM file or a WASM supported file, which is a bin file. And that you can run through a runtime, which is right now it's wasmer is a popular one, but there are multiple runtimes that you can use to run this binary file. Yeah, wasmtime is also there. Yeah. So at least with all the tools that we explored before and this, it seems to be a lesser devil right now. But we want something to be a better tool so that we can ship our apps and whatever we have faster. So while I was going through all of this thing and what it was, so I landed up on this tweet by Solomon, and if you see, it has been done in 2019, and the tweet actually aged very well, because he said that if WASM or WASI existed back in 2018, Docker wouldn't be there. And it was very revolutionizing for me, or revolting for me, because I like containers. I use them a lot. But then he was not talking about containers as such. What he was talking about here is compiled single time and run everywhere. So compile once and run everywhere. And that is a great idea that we took up from here, and we wanted to build over on this idea and maybe get to somewhere where this can be a reality. If you want this tweet or you want to see where it is, there is a QR code you can scan, you can get there.
So with that, I think the issue that we were facing while developing in WASM is basically a runtime where we can just quickly test. And even when we have a compiled .wasm file, we don't know if it's gonna run. We don't know what exports it has. We don't know a lot about it. because we can't see the output of it unless we run it, and then we see that it's crashing or it's not crashing, right? So we wrote this tool. This is an open source project called WASM Run. You can go check it out. We're just starting with it, and right now we intend to add a lot of languages across, so that we can make it language agnostic. It's built using a lot of WASI tools. WASI is another amazing project for WebAssembly system interfaces, and for web, it uses different tools on top of it. But what it can also do is it can inspect you and verify your WASM file. I thought we won't be doing that, but let's just, we can type it. I want to type. Right, so you can actually install it directly.
I don't have
Cargo. So we just generated a .wasm file, and we'll see. We have not done this before, so this is going to be,
so this
it's going to be either
yeah,
it's going to be a hit or a miss, and yeah.
with the time we have, might hit.
Hopefully. So the idea is that while developing, it should be a dev tool where we can just run and test our code and how it's compiling or not in WASM. So let's say, and we have hello.wasm. Let's try to do that. So yeah, as you can see, it shows that it has a lot of. So it will show, like right now, this is an inspect command. So it will show basically what this particular WASM file has. It has 2 import functions, 3 functions, a few export functions, and then no custom functions. But the sizes are huge. As you can see, what this means is essentially that it has added a lot of, like, from the compiler itself, which is not needed. What we would want is that there should be some form of compilation which ignores this part, and it uses only the parts which is required and then creates a bundle of it. The size will be much, much smaller, right? We only need something like this, only this part. This is completely unnecessary. So we are working on another project which can help out towards that, and it's using some parts of it, using, again, WASI, and for Python on the website will be, there are some more projects that you can actually look up. There's another project called PyScript, and for the web part you can go through it. We'll be integrating that as well, so you can run all of that using WASM Run. That's it for this talk. If you have anything to take away from this, is that the Python ecosystem in WASM is quite behind, but there are very active projects which is working towards it, very active organizations which is working towards it, and so are we. If you have any thoughts, feedback, we'd be happy to listen. Any thoughts on the direction that we are going towards, we'd be happy to listen. And with that, we'll be opening up for a few questions, if there are.
All right. There are microphones right here toward the front of the aisles. Let's start with this side, please.
Hi. For sure, a stupid question and a very beginner one. I know why WASM is better than containers and everything, because it was in the presentation. But what is WASM? Like, what is WASM like? Can you explain in a few words?
All right. So I wouldn't say WASM is better or worse than containers. It's just an alternate way to do things. I would say there is a virtual machine which runs somewhere. You can either run it like what container does, right, on a server, or you can run the virtual machine on the browser or any other place as well. WASM is basically WebAssembly, and you can think of WebAssembly as sort of like an instruction set, right? And then you can build on top of it. You can compile things to it. Say at one point you will get a file which then you can run anywhere and so on.
But, okay. Yeah. But like, so it abstracts away the VM part of it, because I know for most containers, it's just they use the same kernel as the actual VM, and they just add files on top of it to be actually, containers.
Right.
Like,
Right. So when you have the WASM file, you can run it on the WASM VM, and then you can access it through other interfaces like WASI and so on. So it's not the VM that you create. You still create a file and which you can run on somewhere.
Also, the comparison that we did was not in terms of the hypervisor and the operating system. The comparison was compile once and run everywhere. I mean, the inception of containers was, it doesn't work on my machine. So you make a container so it can run on everything. So that is the comparison that we are trying to.
Okay.
Yeah?
All right, let's get a question from here, please.
Okay, so much a question. It's just three things. Number one, you didn't mention MicroPython, which is also a version of Python that compiles to WebAssembly. It's very small and it's very fast, so that might be helpful. Number two, there was a talk this morning. No, it wasn't. There was a talk yesterday, even maybe at one of the summits by Antonio Cuni about Spy, which is a Pythonish dialect that compiles to WebAssembly. So that's another thing that maybe you could look to. And there's a guy at Carnegie Mellon University called Ben Titzer, who is a professor there. He was one of the creators of WebAssembly. And one of the things that he's researching right now is how you get scripting languages like Python to run faster on WebAssembly. And what he's looking at is taking the bytecode of Python and converting that into the bytecode that WebAssembly uses as well. It's very early stages, but I just wanted to mention those so that you know about it, but also folks that might have seen the talk also know about those things as well. So that was a really great talk. Thank you very much.
Absolutely.
Thanks a lot.
Yeah.
A question: you used NoITCA to compile Python to C and then to WebAssembly. Did you consider using Python compiling the Python to C and then to WebAssembly?
Yes. So we are not compiling at all in this project. We'll be using some compiler, but yes, ideally we should be using let's say the CPythons or the other Pythons one, so that we can get a C to .c, and then we can either create a WAT file or WASM file from there, or we can use EMCC to directly have the .c to .wasm.
Does that answer your question?
So it's possible. Why did you go the NITCA route if you can only use 3 to 11.0, which doesn't make no sense to go only with one version, because Python supports all Python versions. I don't know if I understood your answer correctly.
Okay. Right. So that's obviously one way to compile it. But we would like to have something which directly does it. The idea is to have. So if we go about with Python, what we are attempting it with the runner is to have like an AOT compiler, which does it on the fly. And as soon as we make some changes, we can have a wash mode, and then it can keep on doing that. Okay. So it should be as fast as.
Okay, we have time for one last question, please.
First, thank you for the talk. I have played around with this ecosystem some time ago, and I read a barrier that for access a network for the runtime was a challenge back in the day. Like if you can compile and doesn't talk with the APIs of the operational system, it's fine. But once you have this, you are really dependent of the runtime. So how is the things is now? Like I remember this was a big thing for WASM runtimes and stuff.
I didn't understand.
Actually, can you repeat the question?
I mean, like if my Python program needs access to the network, for example,
right,
then it's dependent from the runtime, like to give it this resource. And I remember like there are some limitations around it.
Yeah.
Yes. So basically, inside the sandbox environment, you don't get access to anything. You don't get access to the system files, the file system, no clock, no network, anything. But WASI has some projects, and using WASI, you can you get access to different modules. So WASI modules has a HTTP module, it has a clock module, a file system module, and so on. So yeah, we'll have to integrate those as.
And just to add on to this, if you're trying to do similar things in browser, you have capability APIs which is ever evolving. So as we speak, their development is happening and they're adding more support for everything that is needed there.
Okay, thank you.
All right, that's all the time for questions. Let's have another round of applause for Farhaan
Thank you.
and Anirudha.
Thanks a lot.
We now have a 10-minute coffee break outside.